Hello friends, myself R.D. Mazen presenting my video on partial differentiation revision part 3. Example number 1. If u is equal to sine inverse of x plus y divided by root x plus root y, then prove that x square into dot u by dot square plus 2xy dot u by dot x dot y plus y square dot u by dot y square is equal to minus sine u into cos of 2u divided by 4 cos cube u. And to prove this, if you observe the terms of this required expression, it indicates that it is a problem of Euler's theorem. And therefore, here given function is u is equal to sine inverse of x plus y divided by root x plus root y. It is function of function. Therefore, it becomes a case 2 for Euler's theorem. Transferring the sine inverse to left hand side, we get sine of u is equal to x plus y divided by root x plus root y. And therefore, function of u is sine u. Differentiating it with respect to u, we get derivative of sine as cos u. And then to determine the degree, we consider that function on the right hand side of this equation, x plus y divided by root x plus root y. It is function of homogeneous expression. Therefore, that homogeneous expression is this one. We require to obtain its degree. For that, we take x common from numerator. We get 1 plus y by x whole divided by, from denominator we take root x common, it is 1 plus root of y by x. And therefore, we get that transferring this to numerator, we get that power as 1 minus 1 by 2 into some function of y by x. And therefore, here it becomes x is to 1 minus 1 by 2 as 1 by 2 into some function of y by x. Comparing this with the general form of that homogeneous expression, we get degree of that homogeneous function as power of this x. Here it is 1 by 2. Then, by applying Euler's theorem, as it is case 2, the value of this is equal to g of u, g dash of u in minus 1, where g of u is n f of u by f dash of u. Therefore, substituting the value, n is equal to 1 by 2, f of u is sine u, f dash is cos u, and therefore we get that value as 1 by 2. Sine by cos, we get that as tan u. Then differentiating it with respect to u, we get as derivative of this tan, 1 by 2 constant outside, derivative of tan is secant square u. Using this in Euler's formula, we get, by Euler's theorem we have x square dot u by dot x square plus 2xy dot 2u by dot x dot y plus y square dot 2u by dot y square is equal to, that result is g of u multiplied by g dash of u minus 1, and therefore it is equal to substituting the value of g of u and g dash of u. The value of g of u is 1 by 2 times tan u, and g dash of u is 1 by 2 times secant square u and minus 1. Not the required result. Therefore, we have to convert this result to this required form. For that, we have to rewrite that tan as sine upon cos 1 by 2. Secant square nothing but 1 by cos square and minus 1. This one 1 by 2 sin u upon cos u, cross multiplying it, we get 1 minus 2 cos square u divided by 2 cos square u. Therefore, this 1 by 2 and this 1 by 2, it becomes 1 by 4 sin u cos u into cos square u, it becomes cos cube u, and that 1 minus 2 cos square u is minus cos of 2u, standard trigonometric result. And therefore, we get the required result, minus sin u into cos of 2u divided by 4 times cos cube u. Proved. Therefore, this is the problem of Euler's theorem. Case number 2, as it is function of homogeneous expression. Second example, if u is equal to function of 3 terms, 2x minus 3y, second 3y minus 4z, and third 4z minus 2x, then prove that 1 by 2 into dou u by dou x plus 1 by 3 into dou u by dou y plus 1 by 4 dou u by dou z is equals to 0. And therefore, to obtain this, let's consider that 2x minus 3y as the new variable r, 3y minus 4z as a new variable s, and third 4z minus 2x as t. And therefore, we try to draw a tree diagram for this, that u is a function of 3 variables r, s, t, 3 independent variable r, s, t, and this r, s, t again a function of new 3 independent variable x, y, and z. Function of function, and that's why it become a problem for change of independent variable. Then we have to obtain the value of dou u by dou x. Direct differentiation is not possible. Therefore, we differentiate it with respect to r and then r with respect to x. All derivatives are partial as function of more than one independent variable. And therefore, dou u by dou r by dou x plus differentiating u with respect to s and s with respect to x, then differentiating u with respect to t and t with respect to x. With the help of tree diagram, we can develop this formula known as formula for change of independent variable, and therefore it is equals to differentiating r with respect to x is differentiation is 2 into dou u by dou r. Derivative of s with respect to x, no term of x, therefore is differentiation is 0. Differentiating t with respect to x is differentiation is minus 2 dou u by dou t. Then multiplying it by 1 by 2 on both sides, and therefore we get that 1 by 2 into dou u by dou x is equal to 1 by 2 of this, 2 to get cancelled, we get dou u by dou r minus, here also 2 get cancelled, we get dou u by dou t, and we call this equation 1. Differentiating u with respect to y, again direct differentiation is not possible, therefore we apply the same technique, differentiating it with respect to r and derivative of r with respect to y, differentiating u with respect to s and s with respect to y, differentiating u with respect to t and t with respect to y, it is equal to differentiation of r with respect to y, keeping x constant, is derivative is minus 3 into dou u by dou r. Differentiating s with respect to y, derivative is 3, derivative of this term is 0. Differentiating t with respect to y, no term of y is there, therefore its derivative is 0. We call then multiplying that result by 1 by 3, and therefore we get new term 1 by 3 dou u by dou y is equal to 1 by 3 of this 1 by 3 in this 3 get cancelled, we get first term as minus dou u by dou r, 1 by 3 into 3 again get cancelled, we get plus dou u by dou r, dou u by dou s. We call this equation 2. Differentiating u with respect to z, direct differentiation is not possible, therefore first with respect to r, then with respect to s, and then with respect to t, and therefore dou u by dou r, applying chain rule, derivative of r with respect to z, then differentiate u with respect to s and derivative of s with respect to z, differentiating u with respect to t and t with respect to z. Differentiating r with respect to z is differentiation is 0 as no term of z is there. Differentiation of this with respect to z, minus 4 into this dou u by dou s. Differentiating t with respect to z, derivative is 4 into dou u by dou t. Then multiplying by 1 by 4 times. Therefore, it is 1 by 4 times dou u by dou z is equal to this 4 get cancelled, we get minus dou u by dou s. 4 into 1 by 4, this get cancelled, we get plus dou u by dou t, and therefore we have this result number 3. And then we have to take the addition of equation 1, 2 and 3. Therefore we have 1 by 2 times dou u by dou x plus 1 by 3 times dou u by dou y and plus 1 by 4 times dou u by dou z is equal to addition of right hand side term. First one is dou u by dou r minus dou u by dou t minus dou u by dou r plus dou u by dou s minus dou u by dou s and plus dou u by dou t. This dou u by dou r cancel with minus dou u by dou r, minus dou u by dou t cancel with this plus dou u by dou t, dou u by dou s cancel with this minus dou u by dou s, and therefore the sum of all this as 0. Hence result is proved. We get the required result. This is a problem of change of independent variable containing first order derivatives only. Next problem I will discuss where we have to obtain second order derivative. Example number third, if z is function of x and y, and this x and y are again function of new two independent variable u and v, x is equal to u cos alpha minus v sin alpha, and y is equal to u sin alpha plus v cos alpha. Therefore, it is function with two independent variable each. Then prove that dou 2z by dou x square plus dou 2z by dou y square is equal to dou 2z by dou u square plus dou 2z by dou v square. And to obtain it, we try to draw the tree diagram. Z is a function of two independent variable x and y, and this x and y are again a function of two new independent variable u and v. Therefore, we can differentiate z with respect to u, but that direct differentiation is not possible. Therefore, dou z by dou u, how we can differentiate it? Differentiating z with respect to x and then x with respect to u. Differentiating z with respect to x, x with respect to u, plus differentiating z with respect to y and y with respect to u. Using tree diagram. And therefore, we get differentiating x with respect to u, keeping v constant. Therefore, its differentiation is cos alpha constant term outside. Derivative of u is 1. Therefore, we get cos alpha into dou z by dou x. Differentiating this with respect to u, sin alpha constant term outside. Derivative of u is 1. Therefore, we get sin alpha as derivative into dou z by dou y. We call as a equation 1. Every term is operated on z. Therefore, cancelling that z throughout, we get operator dou by dou u as cos alpha dou by dou x plus sin alpha into dou by dou y. We call this equation 2. And operating this operator on this, we get dou by dou u of dou z by dou u, nothing but dou 2z by dou u square. Means we are obtaining the right hand side term. Not necessary that always we have to obtain left hand side. All it depends on the tree diagram. And therefore, substituting the values, dou by dou u is cos alpha dou by dou x plus sin alpha into dou by dou y. Operated on this, that term is cos alpha dou z by dou x plus sin alpha into dou z by dou y. Not a simple multiplication, it is the operation by this operator. Therefore, operating first on this and this on this, we get cos alpha into cos alpha, we get cos square alpha. Dou by dou x of dou z by dou x, we get dou 2z by dou x square. This operator on this, that product is sin alpha cos alpha. Dou by dou x of dou z by dou y, that becomes dou 2z by dou x dou y. Then operating this on this and then this on this, we get sin alpha into cos alpha dou by dou y of dou z by dou x, that becomes dou 2z by dou y dou x. Then this on this we get sin square alpha dou by dou y of dou z by dou y, that becomes dou 2z by dou y square. As per the property of partial differentiation, dou 2z by dou x dou y and dou 2z by dou y dou x represent one and the same. Therefore, we can add these two. By adding these two, we get that result as cos square alpha into dou 2z by dou x square. Addition of that term is 2 times sin alpha cos alpha dou 2z by dou x dou y and sin square alpha dou 2z by dou y square. We call this equation 3. Therefore, 3 steps. First, obtain the derivative of dou z by dou u. From that, get the operator dou by dou u and operate it on this to get result number 3. Here, half part is over. I obtained the value of dou 2z by dou u square. Exactly on the same line, we try to get the value for dou 2z by dou v square. Differentiating z with respect to v, we get dou z by dou v. Again, direct differentiation is not possible. Therefore, we differentiate first with respect to x and then x with respect to v. Therefore, dou z by dou x by dou v plus differentiating z with respect to y and then y with respect to v. Result is obtained using tree diagram only. And therefore, obtaining the derivative. Differentiating x with respect to v, keeping u constant, therefore derivative of first term is 0. Derivative of that second term is minus sin alpha constant term outside. Derivative of v is 1. Therefore, we get minus sin alpha into dou z by dou x. Differentiating y with respect to v, keeping u constant, derivative of first term is 0. Derivative of second term is cos alpha into dou z by dou y. Equation number 4. Every term is operated on z. Therefore, cancelling that, operator dou by dou v as minus sin alpha dou by dou x plus cos alpha dou by dou y. We call as equation 5th. Then operating this on this, therefore dou by dou v of dou z by dou v, nothing but dou 2z by dou v square, required second term. And therefore substituting the values. Dou by dou v, that operator is minus sin alpha dou by dou x plus cos alpha dou by dou y into this term is minus sin alpha dou z by dou x plus cos alpha dou z by dou y. Again, it is not a product only, it is operation by operator. Therefore, operating this on this first and this on this second time, we get minus sin alpha into minus sin alpha, that becomes sin square alpha dou by dou x of dou z by dou x, that becomes dou 2z by dou x square. This into this, that product is minus sin alpha cos alpha. Dou by dou x of dou z by dou y, that becomes dou 2z by dou x dou y. Then operating this term first on this and then this on this, we get, therefore that product is minus sin alpha cos alpha, minus sin alpha cos alpha, dou by dou y of, that becomes dou 2z by dou y dou x, and this operator on this, it is cos square alpha. Dou by dou y of this, that becomes dou 2z by dou y square. Simplifying it, we get sin square alpha dou 2z by dou x square as it is, minus sin alpha cos alpha, and again minus sin alpha cos alpha, addition is minus 2 sin alpha cos alpha, dou 2z by dou x dou y, and this last one is cos square alpha dou 2z by dou y square. We call this equation number 6. And then adding equation 3 and equation 6, we get equation 3 and equation 6. Then by equation 3 plus equation 6, we get addition of left hand side term is dou 2z by dou u square plus dou 2z by dou v square is equal to addition of right hand side term, first with first, second with second, and third with third. Therefore, when we add these first terms, we can take dou 2z by dou x square common. Remaining terms are cos square alpha plus sin square alpha into dou 2z by dou x square plus 2 sin alpha cos alpha cancel with minus 2 sin alpha cos alpha. Therefore, this addition becomes 0. And adding the last two terms, we get again sin square plus cos square alpha remaining term, common is dou 2z by dou y square. And therefore, we know this result, sin square plus cos square alpha is 1. Therefore, 1 into that, we get dou 2z by dou x square. Again, this one is 1. Therefore, into dou 2z by dou y square. Therefore, we get the required result, dou 2z by dou u square plus dou 2z by dou v square is equal to dou 2z by dou x square plus dou 2z by dou y square. Hence proved. In this video, I have discussed 3 problems. One on Euler's theorem and 2 on change of independent variable. In my next video, I will discuss 3rd unit, that is application of partial differentiation. If you like my video, please share it as well as subscribe to my channel. Thank you. Thanks for watching.